Hello guys, today I'll be covering geometric mean. It is kind of different from a rhythmic mean, but on a fundamental level it's kind of similar. Okay, so let's get started. First, I'm going to draw a triangle, a little bit, you'll see why, with a 90-degree angle there, just in case you don't know, it's 90 degrees. And the line that passes through here. Okay, so now we have two different angles, this one and this one. We'll call this one alpha, this one beta. The only thing we know about them is that alpha and beta, if you add them, they equal 90. And we also know that these two are 90. And another thing we know is a triangle has 180 degrees. So, what would we need to add? What would this need to be in order to complete the 180? Well, we've got 90 degrees already. Now we need 90 more. We already have the A, and if we look over here, A plus B is 90 as well, so this has to be B, this has to be A, alpha, whatever. So now we know this A, B, B. This is basically this triangle is similar to this one. It's just, you have to rotate it. Okay. So now let's try it again. Okay, so we have length 1 and length 2, as well as height. We know since if we cut this off and turn it around, we're gonna end up with this, which should be similar to this. So since we know, well, we should know that this divided by this, L1 divided by the height divided by the base should be the same as the height divided by the base. So we end up with this equation. Okay. So now L1 over H is H over L2, which becomes L1 times L2 equals H squared. And we solve for it, we get L1 times L2, square root of that equals H. We solve for H. And this is a geometric mean of two numbers. So what it's just saying is that given that this is 90 degrees and this line is the altitude, the length 1, length 2, their geometric mean is a height. Okay, so enough of that. Let's take a look at the actual equation. It's called pi, not pi, pi. In case you don't know why it's called pi, we have big letters and small letters, A and A. The Greeks also had their small and big letters, so that's basically what it is. Oops. Okay. So now let's write the equation and then I'll explain it. Okay. So it does look intimidating at first glance. Okay, so let's start by dissecting it. First, n, that's the most important one. Basically tells you how many terms there are, how many numbers, how many numbers are there in total. So it's just total numbers. It's just going, this is the first number, this is the second number, all the way until it's the nth number, so it's the nth number. Xi basically just represents the numbers. It's any number. You should at least know what exponentials are to understand this. So okay. Moving on. So how would we write this? I equal 4 x. Well, let's say we have this isn't right. Dot. This is how it would look like. This just represents how many times you need to multiply a number that's the same to get that. So, for example, when we're doing 2, you can also write the second square root just by itself. So since you need 2 times, you need to multiply 3 the same number of times 3 times. The answer would be 3. Let's say we get the third square root of 8. Which number would you need to multiply by itself 3 times to get 8? 2, because 2 times 2 times 2 equals 8. So, okay. So let's do some examples. Let's say we have 4, 8, and 2. So what will be the geometric mean of that? So one strategy I like using is just multiplying them by their prime factors. So 1 plus 2 plus 3 is 6. So this equals 6 divided by 3. You never really have to do any big multiplication there. Okay, so now let's try something a little more hard. For square root of that, it would equal 3 times 3 to the 3 times 2 times 2 to the 3, which would equal the 4th root 3 to the 4, 2 to the 4, which would just equal 3 times 2 because these cancel out. Of course, there's other ways of doing it. There's other ways of doing everything. Let's see. But when you're faced with like big numbers, like I don't know, times it's best just to get a calculator. If not, you could always try estimating. So you know that all these numbers are around 15, right? So let's say the middle number is like 15 or something. Probably is. We got 65 here. That would probably increase the number even more, since we're doing a geometric mean. I believe it's lower than an arithmetic mean. So here, I guess we could estimate it to be, and I don't know, like 20. The answer would probably be between 20 and 30, I would assume. If anything, has to be lower than that. But now, no. When it comes down to like big problems like this, it's best to either estimate or use a calculator. If you're in a situation you can't use a calculator, just do your best to like estimate. Let's see, what's the actual answer? No, I'm actually out of time. So, thanks for watching. And I'll see you guys next time.